Hi everyone, and thanks for joining. Today I'm going to walk you through this bike, very easy Linux box available on Hack the Box platform. This is the 7th box from Starting Point series of machines, so-called Tier 1. You need to walk before you can run. This instance has tags, custom applications, NodeJS, Reconnaissance, remote code execution, and server-side template injection, SSTI, so you can get an idea what you will see and learn from this box. I'll proceed to connect to Hack the Box Starting Point VPN network and spawn the target instance. Upper right corner of my machine shows I'm already connected. I'll refresh the Hack the Box user interface, confirm that. Great, and now it shows the updated view. And I'll proceed to connect to this target bike instance. As usual, I'll go through the walkthrough, focusing on hands-on tasks and answer these questions towards the end of this video. So while we are waiting to get this target instance IP address, I'll start going through the walkthrough introduction. This machine focuses on the exploitation of a server-side template injection vulnerability identified in Handlebars, a template engine in Node.js. This walkthrough will demonstrate how to exploit an SSTI in a web server when the developer doesn't sanitize user input correctly. We will also cover the basics of Node.js, template engines, and global variables, as well as how to escape a sandbox environment with restricted JavaScript commands available. I'll proceed to ping this IP address to confirm connectivity is as expected. Great, and now I'll run this nmap command with switches sc, sv, and -v for verbose, and then target IP. And if in case you'd like to go through a refresher for nmap switches, you can refer to this cheat sheet, for example, that contains explanation for switches mentioned in this walkthrough. For example, for SV scans the discovered services for their versions. SE perform a script scan with scripts that are categorized as default. And -v for verbose and -vv for very verbose displays verbose output during the scan. Some of nmap switches require sudo before nmap to be able to run, though this one doesn't require sudo. We expect to see port 22 reported back as open and port 80. Great, we have that. Port 22 for SSH and port 80 for Node.js Express middleware as shown on the screenshot. Service info Linux. As expected from the TTL, usually we see this TTL for Linux instances, though not a rule of course, but usual, and for Windows 127. Continuing with the walkthrough, the scan reveals port 22 open, however, We will ignore it for now as we don't have credentials or keys that can be used to authenticate. We also have port 80 open, which is running an HTTP NodeJS server and making use of the Express framework. So let's proceed to navigate to the web server. And we should see this field to enter email. We'll proceed to enter this example one as seen in the walkthrough. Sometimes developer put in poor code as a quick solution leading to vulnerabilities. We expect to get this email address reflected back on the page. That could lead us down a trail of thinking about various potential exploitation vectors such as cross-site scripting, XSS. However, we first need to know what frameworks and coding languages the website uses for its backend. And we could confirm that using Webalizer, for example. Okay, let's now proceed with the hands-on part and pause with the walkthrough for now. So let's see that reflected back on the page. There it is. And now with Webalizer we expect to see Express mentioned and Node.js as seen in the Nmap output. And there they are. Okay. So with this information in mind, we can start identifying potential exploitation paths. In a real-world scenario, we would attempt with several payloads to verify an XSS vulnerability. With such payloads, such as script alert 1, which will show as unsuccessful. Let's try this payload for XSS to see for ourselves. Let's see if this payload will be reflected back as is or a character will be missing. It's reflected back as is. So the walkthrough now introduces us to a new term, template engines. Mentioning Node.js and Python web backend servers often make use of a software called template engine. And template engines, like all software, are prone to vulnerabilities. The vulnerability that we will be focusing on today is called server-side template injection. To put it plainly, an SSTI is an exploitation technique where the attacker injects native to the template engine, that is, code, into a web page. The code is then run via the template engine and the attacker gains code execution on the affected server. In order to exploit a potential SSTI vulnerability, we will need to first confirm its existence. And this linked Hacktricks article guides how to identify if an SSTI vulnerability exists and how to find out which template engine is being used. Once the engine is identified, a more specific payload can be crafted to allow for remote code execution. Then there are mentioned several payloads we can use to try to confirm this SSTI vulnerability exists. Let's first try this $, squiggly brackets 7 times 7, close squiggly brackets, to input into email submission form. We saw when we input XSS specific payload, it got reflected back as is, and in case of SSTI exists, after submitting one of these SSTI specific payloads, the web server will detect these expressions as valid code and attempt to execute them. In this instance, calculating the mathematical equation 7 times 7, 7 multiplied by 7, which is equal to 49. We are unsuccessful with this one. Now let's proceed with this payload. And there's an error now. So the web server tried to execute this payload as a code, though something is not quite right, and we have an error, though it might be a useful one. So let's proceed going through the walkthrough. This means that the payload was indeed detected as valid by the template engine, however, the code had some error and was unable to be executed. An error is not always a bad thing. On the contrary, for a penetration tester, it can provide valuable information. In this case, we can see that the server is running from the root backend directory. And also the handlebars template engine is being used. And we'll now refer back to Hactrix for handlebars and the NodeJS specific payload. We see handlebars mentioned here in the diagram. And then we'll proceed to use this payload with Burp Suite proxy and adjust the payload from there, as we will later see. And in case you haven't used Burp Suite before, you can refer to this using web proxies module on Hack the Box Academy, where you can get that introduction. So I'll now proceed to intercept the post request and adjust it with the payload from Hactrix. And this payload should be URL encoded. But let's pause with the walkthrough now and let's do this part hands-on until page 14 of the walkthrough. And let's send this post request to repeater. I'll forward this one now. Stop intercepting. And let's adjust this section for email with payload from Hactrix. Though first, as mentioned in the walkthrough, we'll URL encode it, this payload, with decoder from Burp Suite. Just to mention, URL encoding is also frequently done from CyberChef. And let's disable Foxy Proxy. Though in continuation, we'll focus on working with burps decoder in case there are any task questions that specifically cover instructions from this walkthrough. So let's switch to burps decoder now. And copy paste this payload to decoder. And on the right, let's choose option encode as URL. And let's copy this URL encoded output and paste it in repeater instead of this email payload over here. As seen above among headers, there is content type application xwww form URL encoded. And now we'll click on send. The walkthrough mentions that we should expect to get a response showing an error that states require is not defined. So let's see that in practice. There it is. The walkthrough now proceeds to explain that the template engines are often sandboxed, meaning their code runs in a restricted code space so that in the event of malicious code being run, it will be very hard to load modules that can run system commands, as we tried to do with our payload, which contains the portion with exec who am I. And if we cannot directly use require, this keyword that's not defined when referred directly, we'll have to find a different way. Then let's read through this section. In computer programming, globals are variables that are globally accessible throughout the program. In Node.js, this works similarly, with global objects being available in all loaded modules. A quick Google search using the keywords Node.js global scope reveals this documentation that details all the available global objects in Node.js. It is worth noting that the documentation also showcases a list of variables that appear to be global objects but are in fact built-in objects, and require is among them. Then, taking a closer look at the documentation, we will see that there is a process object available. And we might be able to use this process object to load require further down the line. And we'll proceed to modify payload as follows. So we'll adjust that one main line of the payload, removing this portion from require to the right with process, and that's for now. And let's see this part in the documentation. So this is documentation for global objects. And here we see require listed, but it's mentioned that the following variables may appear to be global but are not. And here is require. and among global objects, there is process listed. Which really is global, and we'll proceed with that. So let's get back to burp and adjust the payload. Essentially, I'll remove this portion of the payload from require to the right and replace it with process. Let's URL encode it and send. Let's copy this URL encoded payload and paste in repeater instead of the previous one. And when I send it, the walkthrough mentions there should be no errors. Great, there's this section as seen in the walkthrough. Now let's read this section of the walkthrough. The response did not contain an error, and we can see the object process has been included. This means that the process object is indeed available. Taking a closer look at the documentation of the process object, we see that it has a main module property that has been deprecated since version 14.00 of Node.js. However, deprecated does not necessarily mean inaccessible. A quick Google search using the keywords Node.js main module reveals this blog post that details the usage of this property. Specifically, it mentions that this property returns an object that contains the reference of main module. Since Handlebars is running in a sandboxed environment, we might be able to use the main module property to directly load the main function, and since the main function is most probably not sandboxed, we'll load require from there. So let's take a glance at this documentation and proceed to adjust the payload by adding .main module to process. So in documentation, here we were on the process object page, then scrolling down, we see mentioned process main module deprecated, and it provides an alternative way of retrieving require main. Generally, it's safe to assume that the two refer to the same module. And second mentioned doc is this one. So let's go back to burp and adjust the payload. Then we expect to see in the output object, meaning this main module property is indeed available. Going back to repeater, let's send this payload again to repeater to open second tab, and we'll proceed working from the second tab. Great, so far so good. Now let's attempt to call require and load a module. We can load the child process module as it is available on default Node.js installations and can be used to execute system commands. Now let's add this .require child process bit to the payload. Then we'll expect to see in the output object again, and after that proceed to attempt to run system commands. Let's proceed from tab 3 now. Great, and now let's adjust the payload once again. And in this main line of the new payload, there is a slight change compared to original payload, which uses exec who am I. And you can find out more about it in this doc. The child process exec sync method is generally identical to child process exec, with the exception that the method will not return until the child process has fully closed. We'll proceed to run the payload as in the walkthrough now. And then we expect to see a root in the output. So let's try that out. In the coder, then let's add this bit .exec sync who am I, encode as URL, copy this URL and encoded payload. In repeater, let's open 4th tab. Great, there's root. So let's now proceed to list root directory instead of asking who am I. We then expect to see flag.txt listed in the output. Repeaters tab number 5. Great, there is flag.txt listed. Now let's proceed to get it out. Features tab number 6. And there are flag characters. Great. Now let's proceed to hack the box user interface to answer tasks questions. Let's save this nmap output to our notes file. Question number 1. What TCP ports does nmap identify as open? Answer with a list of ports separated by commas with no spaces from low to high. So we saw in the nmap output, those were the ports for SSH and HTTP. Task 2. What software is running the service listening on the HTTP web port identified in the first question? That was NodeJS. Task 3. What is the name of the web framework according to Webalizer? That's Express. Task 4. What is the name of the vulnerability we test for by submitting 2 squiggly brackets open, 7 times 7, 2 squiggly brackets closed? That's server-side template injection. Task 5. What is the templating engine being used within Node.js? We saw that was handlebars in this case. Task 6. What is the name of the Burp Suite tab used to encode text? We use decoder. Task 7. In order to send special characters in our payload in an HTTP request, we'll encode the payload. What type of encoding do we use? We used URL. Task 8. When we use a payload from Hacktricks to try to run system commands, we get an error back. What is not defined in the response error? So we saw require was not defined. Task 9. What variable is traditionally the name of the top-level scope in the browser context, but not in Node.js? We found that in the walkthrough in the global section. Task 10. By exploiting this vulnerability, we get command execution as the user that the web server is running as. What is the name of that user? We saw root in our case. And after submitting the flag, we can say we pwn the box. That's all for this video. Like and subscribe if you enjoyed this one. Until next video. Bye for now.